Hello class, this is section 7.4. In this video, we'll work through a problem where we use Laplace transform and properties of Laplace transform to transform the given differential equation into a different differential equation and then find a solution. In this particular problem, we are given that we have to find the solution such that x of 0 is 0. Let us assume that x prime of 0 is some constant k and say x of t is solution. Let x of s is the Laplace transform of x of t. Then the Laplace transform of x prime of t is s times x of s minus x of 0, but x of 0 is 0, so this is just s times x of s, and Laplace transform of x double prime of t is s squared times x of s minus s times x of 0 minus x prime of 0. X of 0 is 0 and we have assumed that x prime of 0 is some constant k, so this is s squared x of s minus. But we see that in the given differential equation the x double prime and x prime are multiplied by t. We know that the Laplace transform of t to the power of n f of t is minus 1 to the power of n, the nth derivative of the Laplace transform. But here n is just 1, so the Laplace transform of t times x double prime of t is minus 1 times the first derivative of the Laplace transform of x double prime, so s squared x of s minus k, which is equal to minus 2s times x of s minus s squared times x prime of s. And similarly the Laplace transform of t times x prime of t is minus 1 times d over ds of the Laplace transform of x prime of t, which is s x of s, and this is equal to minus x of s minus s times x prime of s. Now taking the Laplace transform of the given differential equation, Laplace transform of t times x double prime plus 3t minus 1 x prime plus 3x equal to 0. We know that this is a linear operator, so it's equal to Laplace of t x double prime plus 3 times Laplace of t x prime minus Laplace of x prime plus 3 times Laplace of x equal to 0. The first term is equal to this, so let us write it here, minus 2s x of s minus s squared x prime of s plus 3 times the Laplace transform of the second term is minus x of s minus s times x prime of s, and the Laplace transform of x prime is s times x of s plus 3 times Laplace transform of x is x of s, and this is equal to 0. We have two terms having x prime, so let us write them together, minus s squared minus 3s x prime of s, and we have 1, 2, 3, 4 terms having x of s, so we have minus 2s minus 3 minus s plus 3 x of s equal to 0. 3 and minus 3 gets cancelled out, so we have x prime of s times minus 3s minus s squared equal to 3s times x of s. Therefore x prime of s divided by x of s is minus 3s divided by s squared plus 3s, which is equal to minus 3 over s plus 3. So we have the new differential equation to be x prime of s divided by x of s equal to minus 3 divided by s plus 3. Integrating, we get x of s is some constant divided by s plus 3 whole cubed. X of t, the solution is the Laplace inverse of x of s, which is k times Laplace inverse of 1 over s plus 3 whole cubed. We have that Laplace transform of t to the power of n e to the power of minus at is equal to n factorial divided by s minus a to the power of n plus 1. Here we have n equal to 2 and a is equal to minus 3. So we have Laplace inverse of 2 over s plus 3 whole to the power of 3, which is 2 plus 1, is t squared e to the power of minus 3t. Therefore, x of t is equal to k over 2 t squared e to the power of minus 3t is the solution. We can write k over 2 as a new constant c, which gives that the solution is x of t is c times t squared e to the power of minus 3t.